Okay, so linear inequalities are sort of like equations, but we simply cannot call them as equations, because if you have y equals 2x plus 5, what we have there is an equal sign. So we call the entire part as a linear equation. But what if we don't have an equal sign? In other words, we have signs such as then y less than 2x plus 5, y greater than 2x plus 5, y less than or equal to 2x plus 5, y greater than or equal to 2x plus 5. All of them are called linear inequalities. The reason why we still call them linear inequalities is because we have the same function, which is a linear equation up here. And all I did is I took that linear equation and I changed it into an inequality by switching the signs from equal to a different sign, that is less than, greater than, less than or equal to, and greater than or equal to. So what we have now are 4 different possible linear inequalities. A very important remark about linear inequalities is that anytime we have a linear inequality, we end up having a lot of possible solutions. What do we mean by that? So let's consider so that is the line y equals 2x plus 5. And if I plug in 0, I get 5 as an answer. So when x is 0, y is 5. When x is -1, I could plug that in the equation and I would end up getting 3. When x is -2, I'd end up getting 1. When x is 1, I would get 7. And when x is 2, I will get 9. So every single point that I wrote in that table would lie on that line. So a point there, a point there, and so forth. So for an x value, we simply end up getting a single y value. So we have a unique solution for each value of x. So the remark here is, if we have an equation, then so if I pick a single value of x, there has to be a single value of y. And that could only happen with equations that are well defined. Now, later on, we would see that there could be two possible solutions, but let's not confuse an inequality with that. So what we are trying to say is, if I pick -2, I simply get the value y equals 1. If I pick 0, I get the value 5. So for each value of x, I have a unique value of y. Now that is with an equation. But however, if we have an inequality, for a given value of x, I could have infinitely many values of y. So in other words, we would have a lot of solutions for y, not just a single one. So infinitely many values in the sense that infinite solutions for y. Now, this would hold true regardless of the type of inequality. May it be less than, may it be greater than, less than or equal to, greater than or equal to. It does not matter. No matter what inequality we have, we're going to end up having infinitely many solutions. The key thing to note, though, is the dotted line and the solid line notation. So when I do an example, it would make sense. When we put dotted lines and we use it in greater than or less than inequalities, indicating I'll just leave it there, and when I do an example, I would explain. On the other hand, we use solid lines to represent, or when we sketch greater than or equal to, or less than or equal to inequalities. So we're going to do a bunch of examples on inequalities. So how do we proceed? The first thing to do is to treat any inequality as an equation. The next step is to determine whether we put a solid line is required. And once we are done with that, since we have infinitely many solutions, we won't have a single number, rather a shaded region. An entire region in the plane would be a solution. So the last step would be shade the region of all possible values. So I have x less than 2. So the very first step is I'm going to treat x less than 2 as x equal to 2. So just in the first step. Now x equal to 2 is a vertical line that passes through 2. Now I'll move on to step 2. We have to determine whether it is going to be a solid or dotted line. Now we use dotted lines for less than and greater than, solid lines for less than or equal to and greater than or equal to inequalities. So since we have less than, it clearly has to be a dotted line. So going to put dotted lines and the next step is to see, well, which side the solution should lie. Should it be to the left of 2 or to the right of 2? Since we see less than 2, the solution has to be to the left of 2. So the solution region in this case I have to fill everything here. Bear with me a minute. So no gaps, nothing, and everything here is included. And that would be the solution to this particular inequality. So the reason why we put a dotted line is because we can't include the values that lie on the line because we have a strictly less than sign. So moving on to the next example, we have x greater than negative 3. So the very first step is to look at the corresponding equation. The corresponding equation is x equals negative 3. And x equals negative 3 is a vertical line that passes through negative 3. The next question to ask is, should it be dotted or should it be solid? Since we have a greater than sign, we have to put a dotted line passing through negative 3. And the solution would be everything above negative 3 because we have a greater than sign. An easier way to remember this in a problem like this is which side is the arrow pointing, or the sign pointing. But I don't want to reinforce that idea, because when we have a slanting line, then you have to focus on the greater than and less than part rather than the direction it is pointing. So in our case, the solution would be all of that. Let's try that. And that is the solution to the inequality x greater than -3. So what we have here is 3x plus 1 is less than or equal to 1. Some of you might look at the inequality and immediately recognize that there is a line in this equation. But if you don't, not a big deal. What should we realize? Well, we have to treat it in step 1 as if it has an equal sign. So we have 3x plus y equals 1. And conventional wisdom tells us that if we have x terms and y terms, we keep the y terms on the left-hand side, move everything to the right-hand side. So y would be -3x plus 1. And we look at the equation that we have, and that is the equation of a line, y equals mx plus b. We know the y-intercept. The y-intercept is at 1, and the slope is -3. So I'm going to sketch the y-intercept. We need another point to find the, or to draw the line. So I'm going to plug in, say, 1, and if I plug in 1, I'd have 1 minus 3, which is -2. So the point would be over here. Now I'm putting a solid dot because I have a less than or equal to sign, so it has to be a solid line to begin with. So I would simply draw a solid line . Close enough. So through those 2 points. And why do I draw a solid line? Because it is a less than or equal to inequality. Now the question is, should I look to the left or should I look to the right? Or which side should I shade? Since we have a less than or equal to sign, we're going to shade everything to the left of the line. So the solution would be everything to the left of the line. And clearly, there are infinitely many solutions, and we call infinitely many solutions because if I arbitrarily pick a point there, that is a solution. Point there is a solution. Point there is a solution. Every single one of those values would form a solution. And that is why we say infinitely many solutions. So what we have here is y less than or equal to negative 2x. So the corresponding equation is y equals minus 2x. And we know we could rewrite it as minus 2x plus 0. So the slope is negative 2. The y-intercept is 0. So when x is 2, y is negative 4. And the y-intercept is 0. So all I have to do is draw a line through the 2 points. That's close enough. And the next thing, I put closed dots or solid dots because I know that I'm about to draw a solid line. Otherwise, I would have put like an open dot. So I just have to shade to the left because we have a less than or equal to sign. Oops, I have to erase that part. No. So I shouldn't exceed the line, so which is why I try to erase. But you get the picture. Even if you see some fills over there, doesn't mean that they are not solutions. I just am not a great artist, that's all. Okay. So here we have another equation. So 2x plus 6y less than or equal to 12. So the very first step, or another inequality. So the first step is to write the corresponding equation, which is 2x plus 6y equals 12. Oftentimes, people will just jump right in and say, okay, I'll start drawing stuff. But always ask the question, could I simplify this equation prior to proceeding? So if you look at it carefully, there is a 2 in 2, there is a 2 in 6, and there is a 2 in 12. So first I'm going to divide everything by 2 on both sides. So we have 2x over 2 plus 6y over 2 equals 12 over 2. The x's would go away. 6y over 2 is 3y. 12 over 2 is 6. Now you should realize, okay, all the x terms and the numbers should be on the right-hand side, and only y should be on the left-hand side. So 3y would equal to 6 minus x. To write it in proper order, we'll have negative x plus 6. But we need to have only only y on the left-hand side. We don't want that 3. So divide by 3 on both sides. So we have negative x over 3 plus 6 over 3, and 3y divided by 3 would simply be 1. So y would equal to, I could write this as negative 1 over 3 multiplied by x. It's the same thing. 6 over 3 is 2. So the slope is negative 1 over 3, and the y-intercept is 2. So I certainly know that the y-intercept is 2. I just have to find the next point. If I plug in 3 in the equation, I would end up getting 2 minus 1, which would be 1. So it would be right over there. So all I did is I plugged in x is equal to 3, which gave me the second point. Now I'm going to draw a line through it. And it is a solid line because we have a less than or equal to sign. And since it is less than, we're going to shade below the line because it is less than. If had it been greater than, then we would be shading above the line. And that would be the set of all possible solutions for the given inequality. Good. So five x plus 3y is equal to negative 15 would be the corresponding equation. I'm going to move all the x's to the other side. So 3y would be equal to negative 5x, negative 15. And I need y by itself on the left-hand side. So I'm going to divide by 3 on both sides. So y would equal to negative 5 over 3 times x. Negative 15 divided by 3 would be negative 5. So that would be the slope. And that is the y-intercept. Now, I'm going to be a bit cautious here when I put the points because I look at the sign and the sign is a greater than sign. So there is no equal to there. So I'm going to put an open dot indicating that we are going to draw a dotted line. And if I plug in, let's see, if I plug in 1, I have plug in 3. Get negative 10, how about minus 3? Minus 3 would give me 0, and that would be an open dot also. And I have to draw a dotted line. Then I have to look at the side where I should shade. And since this is a greater than sign, I'm going to shade on the right-hand side. You don't have to be precise when sketching, you just have to understand the concept. And that is it, and that would be the solution in this case. So in this problem, we're just going to do what we did earlier in reverse. In other words, we have a graph, but we have to write the corresponding inequality. All we have to do is follow the steps in reverse. First, you look at the graph and you realize this is a vertical line. And a vertical line's equation is always x equals something. In this case, it is passing through 2, so we're going to put 2. Step 2. Is it greater than or is it less than? Well, we're shading on the right-hand side, so it has to be x greater than 2. But then you look at the solid line. So since there is a solid line, I have to put greater than or equal to. And that's how you determine the inequality, just by looking at a graph. In the second one, we have a horizontal line, and we know that the equation of a horizontal line is y equals something. In this case, the line is passing through 1, so the equation of the line is y equals 1. The next step is to ask ourselves, well, should we put a greater than sign or a less than sign? It has to be greater than, because everything here is bigger than 1. So bigger than 1, bigger than 1, bigger than 1, and so forth. So it's definitely greater than 1. And should we put a greater than sign or greater than or equal to? Since we see a solid line there, it has to be y greater than or equal to 1. Okay, first step, you look at the line and it is vertical, which would mean x has to be equal to 1. Step 2, should we look on the left-hand side or right-hand side? Well, they're shaded on the left-hand side, so it has to be a less than sign. An easier way to look at it is every single x value here is less than 1. The next step is, should we put less than or equal to? Since we have a dotted line, it has to be less than or equal to. I believe that's the last problem. So here we have a horizontal line, which tells us that the equation has to be y equals something, and that number is -1. And should it be a greater than sign, a greater than or equal to sign? Well, we have a dotted line, so it has to be strictly greater than or strictly less than, but every single y value here is bigger than the line. So this has to be y strictly greater than -1. And that's how you graph inequalities.